All right, we are in Chapter 7, Lesson 3, solving equations with variables on both sides. Solving equations, so we have an equal sign. With variables on both sides, that means we have x's or whatever our variable is on both sides. So it could be something like this, 2x plus x equals 3 plus 2x. You know, we have variables on both sides of the equation. So that's what we're going to be doing for this section. So it says to solve multi-step equations with variables on both sides, first combine like terms and clear fractions. So let's just say combine like terms. Okay. Then add or subtract variable terms to both sides so that the variable occurs only on one side of the equation. So then get the variable on one side of the equation. Then use properties of equality to isolate the variable. Then use properties of equality to isolate the variable. So let's go ahead and talk about this. First, we are going to combine like terms on each side of the equation. Each side of the equation. Then we are going to get the variable on one side of the equation. And then lastly, we are going to isolate the variable and figure out what it is. Get it all by itself. Isolate the variable and figure out what it is. Okay, so let's go ahead and practice this. So example 1A looks like this. All right, and we are going to solve. If you see, there's a variable on this side of the equation, and then there's a variable on the other side of the equation. So first it says to simplify. So I'm looking on this side of the equation. Is there anything I can simplify? Nope, it looks pretty simplified. What about on this side? Nope, looks pretty simplified. So what I'm going to do is I'm going to get the variables on the same side. Now, for the most part, what I always like to say is, hey, you know what? I'm going to move the smaller of the two. So out of 4x and x, which one's smaller? Well, x is smaller. So I would move that one over here. However, since x is already over here, this is like the one exception, like the loophole to my little rule. Since x is over here already by themselves, what I'm going to do is move this 4x over there so then the x is already somewhat isolated on this side of the equation by itself. So I'm going to do the inverse. This is a positive 4x, so the inverse of that would be a negative 4x to both sides. That cancels. I'm left with 6 equals x minus 4x, which is a negative 3x. Okay, now I have the variable is on one side of the equation all by itself. I mean, not all by itself, but they're now combined. The variables are combined. Now it's time to isolate it. So this is a negative 3 multiplied by x. So we need to do the inverse operation, which would be a division of negative 3 to both sides. 6 divided by negative 3 would be negative 2 equals negative 3 divided by negative 3 is just 1x. And use the symmetric property of equality to say x is equal to negative 2. Are we done? Oh no, we are never done because we are always going to check our answers by hand because it is our favorite thing to do. It's my favorite thing to do too. All right, Pause Dragon. Sweet. So we are going to do this one for you. So write the original equation always. And then we are sticking in negative 2 for x. So 4 times negative 2 plus 6 equals negative 2. All right. Order of operations, we are just going to work one side of this equation at a time. So 4 times negative 2 would be negative 8 plus 6 equals negative 2. Negative 8 plus 6 would be negative 2 equaling negative 2, which is a true statement. Awesome. Which means that x equals negative 2 is the solution to the original equation. All right, that is awesome. X equals negative 2 is the solution to the original equation. All right, let's move on and try this again. Okay, what do we have here? Ooh, There's a little bit more action going on. Okay, so we have a variable on this side. Now we have a variable of b, and we have a variable over here. So I'm just going to draw this down. Okay, the first step is to simplify on each side of the equation. So is there anything I can simplify here? Nope. Over here? Nope. So I want to get the variables on the same side. I'm going to move the smaller. So out of 9b and 5b, which is smaller? I would say 5b. So we're going to do the inverse of a positive 5b, which would be a negative 5b to both sides. We have 9b minus 5b, which is 4b, minus 6, that just drops down, equals, that cancels, 18. All right, now it's time to isolate b, and we just have a two-step equation. So we're going to do the opposite of negative 6, which is positive 6 to both sides. That cancels. We're left with 4b equals 24. A little division of property of equality action, and we're left with b equals 6. Sweet. Okay, now it is time to check it by hand. Write the original equation, original equation, original equation, original equation. Every single time, every single time, every single time. Okay, now we're going to plug in 6 for b. Okay, so we have 9 times 6 minus 6 equals 5 times 6 plus 18. Do these equal? I don't know. We're going to figure it out. So we have to do order of operations. 9 times 6 is 54 minus 6 equals 5 times 6 is 30 plus 18. 54 minus 6, what would that be? I think 48, right? And 30 plus 18, 30 plus 10 is 40, plus 8, 48. Hey, all right. So this is a true statement, which means what? It means the number that we stuck in for b right here. Here was b, and we stuck in a 6. So that means b equals 6. That is the solution to the original equation. All right. We are going to move on to the next example. And the next example is 1c. This is a very lovely example. Okay. Ooh, this looks like fun. All right. Here we go. We have 9w. Ooh, w. 9w plus 3. I'm going to change up my pen. I'm tired of that pen. We're going black. 9w plus 3 equals 9w plus 7. Okay. So we're going to look at each one of these sides. Can we simplify this side? That is simplified. Can we simplify this side? That is simplified. Okay, now it's time to get the variables on the same side. Well, which one is smaller? Well, to me, it looks like they're the same. So I'm just going to pick one. Okay, I'm going to move this one, this 9w right here. So it's positive. I'm going to move it. I'm going to do the inverse operation, which would be a negative negative 9w to both sides. Okay, now what happens here? 9w minus 9w equals 0w. Oh my gosh. Okay, so that's 0w. That cancels, no problem. I'm left with 3 on this side. But then 9w minus 9w, that cancels out too. And I'm just left with 7. Hold on. Okay. I have a question. Is it okay if the variables cancel? Ooh, that's not how you cancel out. Is this okay? Is this okay? Because right now, I feel like I'm kind of freaking out. I feel like this is a wow moment. Like, what is going on? I don't know. Is this okay? And the answer is, drum roll, please. Yes, it is okay. It is completely okay. I know it feels so horribly wrong and out of character, and it just feels like that should never happen, never, ever, ever, but it is totally okay. Now, this is going to happen where the variables cancel out, and that is completely okay. What that means is it means 2 things. How many things? 2 things. Yes, this means 2 things. So if the variables cancel out, it means how many things? Yes, 2 things. It means 1, 2. Let's talk about the first. So if they cancel out, it's totally okay. What you're going to be end up with is something like this. 3 equals 7. Well, does 3 equal 7? No, it does not. 3 does not equal 7. What that means is that is a false statement. Okay? It's a false statement, which means there is no solution. No solution at all. None. And what does no solution mean? Well, that means if I have the original equation, 9w plus 3 equals 9w plus 7, it means that there's no number that I can stick in here for w and here for w where the equation will equal each other. So let's look. Let's just pick like w equals 1. All right, w equals 1. If I put 1 in there and I go 9 times 1 plus 3 equals 9 times 1 plus 7, well, this is going to be 9, right? And this is going to be 7. And 9 plus 3 is 12. And 9 plus 7 is 16. And it's never, they're not equal to each other. So, this is just w equals 1, but really any number that you put in, it's never going to equal. And really the reason why is because when you stick in the same number and it's multiplied by 9 right here, like that, right? You're always going to get the same value when you stick the same number in for w and then multiply it by 9. You're always going to get, that's always going to be the same. But since right here, they add that same value, they add 3 to it, and then over here, they add 7 to it. So no matter what this value is, that same value, they're adding 3 to it on this side of the equation, and then that same value, they're adding 7 to it on this other side of the equation. So it doesn't matter whatever you stick in for w, whether it's a fraction, a positive number, a negative number, it's never going to equal. And that is why it is no solution. Okay, so this is something that's found when you're solving an equation and then you're trying to get the variables on the same side and then they cancel each other out. And I know that it feels horrifically wrong, but it is okay. I promise you, it is okay. So you just need to breathe through it, and then you look for the next thing. So when they cancel out, what are you left with? Well, here we were left with 3 equals 7. That is totally a false statement. That's a false statement. It's not true. It's false, which means for this, the answer would be no solution. And the thing I love about no solutions is you don't have to check them by hand. There's just no solution. That's it. Okay, so the question arises, what if we were doing an equation like, let's say this, where it was 9w plus 3 equals 9w plus 7, and we get the 9s on the same, I meant to say 9w plus 3. I'm sorry. Okay, so I'm changing the equation up. I'm just flipping the script a little bit. Okay, we get the 9w's on the same side. Oh my gosh, the 9w's cancel out, and it doesn't feel right. It feels wrong, but it is okay. All right, and what we're left with is it cancels, and we're left with 3 equals 3. Now, what is this? This is a true statement. True, so this is totally true. 3 does equal 3. That is a true statement. So what this means is that there are infinite solutions. Now, what on earth does infinite solutions mean? Well, what that means, if I was to do a check by hand, right? And I had 9w plus 3 equals 9w plus 3. And let's say I put in my w equals 1. And I get 9 times 1 plus 3 and 9 times 1 plus 3. Well, I get my 9 times 1 again like I did over here. So that's always going to be the same number. But now, instead of adding that different numbers, now I'm adding the same number to both sides. And so 9 times 1 plus 3, that's going to be 12 on this side. And 9 times 1 is just 9 plus 3 is going to be 12. So it's going to give me a true statement. Okay? And let's go ahead and try it again with a different number. So I'm going to write the original equation. 9w plus 3 equals 9w plus 3. And let's do it with you know, a negative number. Why not?